We're good, thank you. Sorry for the delay. Classic, even in the future, nothing works. Welcome. I am Todd. I am an engineer at Rap Genius, and today's talk is going to be about data science with a live tutorial. And before we get into the live coding component, I wanted to show you all a project I built previously, which kind of serves as the inspiration for this talk, sort of. So this is a website called weddingcrunchers.com. What is Wedding Crunchers? It's a place where you can track the popularity of words and phrases in the New York Times wedding section over the past 30-some years. And a lot of you might be wondering why on earth would this be interesting or relevant or funny or anything. And I hope to convince you that very quickly. Here is an example wedding announcement from the New York Times. This one's from 1985. If you don't know, maybe you don't live in New York, read the New York Times. The wedding section has a certain cultural cachet. It's kind of an honor to be listed in there, and it's got a very resume-like structure. People get to brag about where they went to school and what they do. So here's an example. Diane de Cordova is marrying Michael Monroe Lewis. They both went to Princeton. They graduated cum laude. She works at Morgan Stanley. He works at Salomon Brothers in New York, and he's going to go to London. And this should be maybe a little familiar to a bunch of you. Mr. Lewis and Associates, Salomon Brothers. This is Michael Lewis. He's going to write Liar's Poker, famous book about his experience there. And before he was a famous writer, he was just another New York Times wedding announced person. And so what Wedding Crunchers does is it takes the entire corpus of New York Times wedding announcements back to 1981, and you can search for words and phrases, and you can see how common those words and phrases are by year. So this is a good one that's relevant to people here, banker and programmer. For example, when you list, so-and-so is a banker or is a programmer in the announcement, and you see over time, banker used to be way more commonly used than programmer in these announcements. And only just this year, in 2014, programmer has finally overtaken banker as the place that people getting married in New York who are part of society come from. Another good one is if you look at Goldman, Sachs, and Google. Is my internet on? Oh, you're good. So here's another good one. So Goldman Sachs, classic New York finance institution. Google, new kid on the block, tech scene, boom, taking over. And this is obviously fun. It's amusing, but it's also actually pretty insightful for a relatively simple concept. I mean, this one graph tells a pretty powerful story of New York, the finance capital of the world. Meanwhile, we have this sort of emerging tech scene. Google may be the biggest player in the kind of new tech world. And now, when you turn to the society page to see who's getting married, there's more employees from Google than there are employees from Goldman Sachs. And that's kind of an interesting thing in the world. And so what we're going to do today is build something just like Wedding Crunchers, except instead of using the text of wedding announcements to analyze, we're going to look at all of the RailsConf talk abstracts. And so hopefully this is interesting to people here. And I always say, if there's only one thing you take from this talk, really what it should be is that work on a problem that's interesting to you. Because especially when you're dealing with data science, a lot of it's pretty messy, and you have to go through scraping stuff, as we'll get into. And it's easy to get frustrated and kind of lost. And if you're not working on something that you care about and something that you really want to know, kind of the final result, it's just much easier to get distracted and kind of ultimately bail. So again, if you take one thing, just work on something that is interesting to you. So the particular kind of analysis we're going to do is something called Engram Analysis. And I have a little example set up here. So what is an engram? You may have heard the word before. Really, all it means is a consecutive words as part of a sentence. So examples are very simple, very one sentence. This talk is boring. What are the 1 grams in this sentence? It's just the words. This talk is and boring. The 2 grams are every pair of consecutive words. This talk is boring, and so on. And so what we need to be able to do in order to build a graph like this is we need to take a term that's relevant to RailsConf, say something like Ember or whatever, and we need to be able to look up for each year how many times does this word or engram appear in the data. And so that is what we are going to build. And I have this brief little outline here. There's kind of 3 steps, and this is pretty general to any data project. Step 1 is going to be just gathering the data, getting it into some usable form. Step 2 is going to be kind of the analysis part where we do the engram calculation, we store the results. And then step 3 is going to be to create a nice little front-end interface that lets us investigate, visualize, and see what we've done. Now, unfortunately, in a 30-minute talk, we can't possibly do all of this. So we're going to focus more on items 1 and 2 and less so on 3. And even then, it's too much. So I sort of use the analogy. It'll be a bit like watching TV on the Food Network, where we might throw something in the oven, mysteriously something else pops out of the other oven, even though it's where did that come from? But not to worry, everything is also on GitHub. There's a repo I'll share with you at the end. So anything that we don't cover or that we covered too quickly or something, you'll be able to see sort of the full version on GitHub. So let us jump in now to step 1, which is gathering the data. And so let's take a look back at the RailsConf website again. So we have to figure out how are we going to model a RailsConf talk in our database. So like what attributes does a RailsConf talk have? And so like one thing we see is they all have titles. So that looks like something. They have speakers. There's this thing, which is the abstract, and then there's the bio. And that's probably it. That's probably all we need. So that's pretty simple. And I have a little migration I've already run here, but here are attributes for talks. It's just the year, what conference were we actually at, the title of the talk, the speaker, the abstract, and the bio. And so also, that's, again, pretty straightforward. The gem file is also very simple. It's mostly pretty boilerplate Rails 4, Ruby 2.1. The only gems I wanted to call out here are we're going to use nokogiri for fetching or parsing websites and kind of scraping the data we need. We're going to use Postgres, our main data store, and we're going to use Redis to build these sort of index that we can ultimately use to look up how common a word is. And so one thing that's not here is like gem fancy data algorithm. And a lot of people, this is kind of where Ruby often gets a bad reputation of not being supportive of scientific computing or whatever, and other languages have more support. But my claim is that it's really not that important. You can get a ton of mileage out of very simple tools that you can build yourself. You don't need a fancy gem or any fancy algorithm. Those things are cool too, and they have their place, but they're not needed a lot of the time. And Ruby is a wonderful language for especially scraping stuff from the web. There's a ton of support there. And so I don't think that the lack of fancy algorithm gems should necessarily be a deterrent at all. And so hopefully part of this talk is convincing people that Ruby and Rails are actually quite well suited to problems like this. OK, so now we actually need to write some code to scrape the talk. And if you've ever done anything like this before, you know that Chrome Inspector is your best friend. So let's fire that up. We're going to inspect element. And so what we need to do now is take this HTML on the page and turn it into a database record that we can then use to our advantage later. And so it looks like all the talks are in these session classes. So that's something. We can look in here. OK, this looks like something. So let's make this bigger. And it helps to, it's kind of essential to be decent with CSS selectors here, because that's how we're going to basically find stuff. So let's see. OK, so there's 81 session divs. That sounds about right. I happen to know that mine is number 78. So let's look at that. And so here we are. So we need to, again, the things the attributes we're storing are the title, the speaker, the abstract, and the bio. And so we're going to need to pull these things out. So let's see. It looks like the title is in this h1 element inside the header. So let's just make sure that works. Header h1. That looks right. The speaker looks to be the header h2. Cool. Now the abstract is in this p tag, so we can do something like this. But this is actually not quite right. So what's wrong with this? Well, the abstract ends suited to the problem. The bio here is also in a p tag, originally a math guy. And we've actually pulled all the p tags. So we need a way of not doing that. And this is where you just need to know a little bit of CSS. Not very complicated. But if you use the little greater than guy, what this says is only take the p tags that are immediate descendants of the session div. And so now we have only the abstract. And lastly, the bio is just in its own little section. So something like that. Cool. So that is the jQuery version of it. We need to do this, though, in Ruby. And as I said, this does sometimes get a little tedious, but let's write the code. So I have this empty method, create RailsConf 2014 talks. And also this method I've written already called fetch and parse, which just gets a URL and sends it to Nokogiri, which we can then use to do our CSS selectors. So let's just write this. So we can say doc is fetch and parse. The URL is this. Let's see if this works in the console. Of course, in here, I might say talk. Do I have internet? Nice. So we can then check the same thing. Again, looks right. Let's find my talk, which this part I couldn't possibly tell you. When you use the Nokogiri, the EQ thing, you have to add 2 from whatever jQuery does. So I'm number 80 now. Don't ask me why. I couldn't possibly tell you. But maybe someone here knows. Be curious to find out. So there it is. There's the title. So let us now write some code here. We have our document. We're going to go through each session. The CSS method is kind of like the selector for Nokogiri, each element. And so for each of these, we're going to create a talk. And again, so the year we already know is 2014. The title we're going to say is header h1, inner text, speaker, header h2, getting there. All right, so I think this will probably work. Let's find out. And so we're back in here. And just to prove to you that I'm not lying, here's 2014. .count. There's none of them. What do I call this method? This guy. Delay job. All right, so we just did something. Did it work? Nice. We got 81 talks. Most importantly, let's. We have my talk, so that's the only one that matters anyway. And so, you might be thinking now, like, what the heck? I came to the data science talk, not the scraping talk. To that, I would say, tough luck. They're the same thing. You might not want to hear it, but guess what? Like, this is usually the most important part of the entire project. It's the hardest part, because guess what? Just because we got the 2014 talks. Now we have to get the 2013 talks and the 2012 talks, and they're all on different websites. They all have different structures. You have to write different code to get each type of website. It's a pain. And this is why I said earlier, really make sure you're working on something you care about, because it's just not fun to in 2008 they separated the speakers and the abstracts. And it's annoying. But again, it's the most important part, I would say. So much of data science is taking data that's either unstructured or structured in the wrong format to you, and getting it into the way, into the structure that you need to do whatever analysis you want to do. So in this case, that's taking HTML on a page and converting it into a Postgres database. And so we have done that now. And again, take my word that I've done this for the other years as well, back to 2007. And so we have a total of 497 talks in here from RailsConf over the years. And so that's cool. That's basically our data set that we're going to use. And so we can sort of move on to step 2 of the project here, which is do the Engram calculation and store the results. And so let's go back to talk.rb. All this, by the way, is just in app models talk.rb. That's where all this code is. And I have another empty method somewhere called def engrams. And so this method we're going to need to give, it goes on a talk. So given a value of n, calculate all the engrams from that talk's abstract. And so what are we going to do here? So again, let's look at talk.mine.abstract. So here's the abstract, and we need to get engrams out of this. And so the first thing, I've written a little helper method over here, which I've just tacked onto string, called normalize for engrams. And what does this do? Well, it downcases it, because we're going to do case insensitive. There might be cases where you want to keep case sensitivity, whatever. It doesn't really matter. In this case, we're going to go case insensitive. Squish is a nice convenient method that will kind of standardize the white space for you. So like if there's any trailing or leading white space, and if there's like a bunch of middle white space, it'll kill the beginning and ending, and it'll turn anything in the middle into a single space. So that way you just don't have to worry about things like double spaces or other weird things that can happen, because of course it's the web. Whatever can go wrong will go wrong. So make sure that your data is in some kind of standardized format. And the last thing I've done is remove punctuation. And the reason for that is just because there's commas, periods, colons, all sorts of stuff like that. We don't really care about it. And so let's just kill any character that's not either a space or a word character. This is kind of a little like Ruby special regex thing. So we're going to kill punctuation. And so we can actually just mess with this in the console maybe. So let's take our little example sentence. This talk is boring. And let's normalize that for Engrams. OK, all it did was downcase it. And now we want to get that into an array of words, which we can just do with split. Cool. And now there's actually this neat little Ruby enumerable thing, which I didn't know about until pretty recently, each const, which stands for each consecutive. And it takes an argument, a single number, like 2. And what this says is give me all of the consecutive pairs of 2. So if we 2a this, now we have this array of arrays, which looks like exactly what we want. This talk is, and is boring. And so the last thing we can do there is we can just map that array to make these just phrases. So cool. So this is actually the entirety of our Engrams method is just this code right here. So let's copy and paste this into the old method here. So what we want, we're doing this on the abstract. Let's get some new lines here. All right, cool. So again, just to recap, you take the abstract, we normalize it, which means downcase and kill the punctuation. We split it to words. Actually, this should not be 2. That should be n. And then we join those. So let's see if this worked. Oops. So talk.mine again. 1. OK, so here are all the 1 grams, which is just the sequence of words, and that looks correct. And all of the 2 grams also looks correct, I think. Yeah, to get a, get it. Yeah, OK, perfect. And so this is kind of the method we're going to use to decompose these talks into just an array of words and phrases. And so what is the next step now that we have this method? Well, the next step is we have to build these indexes that we're actually going to use to look up the final results. And so for that, we're going to use Redis. Now, we don't have sort of enough time to really get totally into the details of Redis, but the thing that we're really going to use is the sorted set data structure, which I definitely encourage you to check out. It's a great data structure, great feature of Redis. And so what is a sorted set? Well, it's got the word set in it, so that tells you something. It's unique elements. And the neat feature of a sorted set is that each element in the set also has a score associated with it. So the way we can use this is, remember, again, the question we want to answer is like, if someone searches for Ember, how many times was Ember mentioned in 2007? How many times was it mentioned in 2008? How many times was it mentioned in 2009? So we're going to have one sorted set for each year, where the members of the sorted set are all the words and phrases that appeared in RailsConf talks. And the scores are the number of times that those engrams appeared. And then Redis is very efficient about this z-score method. You can look up, so like this command right here would say, OK, in the sorted set for 2014, get me the score associated with the member Ember. And that's going to tell you some number, like 3 or whatever, is the number of times it gets mentioned. So what we have to do is build these sorted sets, one for each year again. And again, I have an empty method called generate engram data by year. So iterate through all talks from a given year, calculate the engram counts, and add to the appropriate Redis sorted set. So let's write that. So one thing we need to do is make sure we're not double counting. So if we have an old sorted set sitting around, let's delete it. So let's delete year. We need to decide what values of n we're going to use. So let's just say 1, 2, and 3, meaning we're going to calculate all the 1 grams, 2 grams, 3 grams. Anything longer than that, and it's sort of like, what's even the point? You're getting into pretty specific sentences. There's not going to be a lot of repetition. So now we need to iterate through each talk for the given year. So where year is year, find each. And then for each talk, we need to iterate through each value of n. And then for each value of n, what do we need to do? We need to calculate the engrams. So we have talk.engrams. This is the method we just wrote. We're going to pass it n. Do engram. And then finally, we're going to add this to the relevant Redis sorted set. So the command for that is redis z incr by. And this goes, you give it a year, you give it a number, like 1, and you give it what are you incrementing. OK, so let's look at this method now. We're going to give it a year. We're going to go through every talk from that year. We're going to go through values of n, which is 1, 2, and 3. So let's say 1. OK, get the talk, calculate all of its 1 grams. And then for each 1 gram, add to the year sorted set the value of 1 for that engram. And then do that just a bunch of times. So let's see if this works. Let's reload. Again, to prove I'm not lying. There's nothing in Redis at the moment. Oops. Got to do talk. Let's work off those delayed jobs. Perfect drink break. So it's going through each year now, and each talk in each year, counting up all the words and phrases, and building our sorted sets. And it is done. Let's see what we got in here now. OK, cool. So we got these keys. Let's look into one of these. So one of the nice things about the sorted set is you can, of course, sort by it. And so the command here is zrevrange. So we can do the 2014 sorted set. So this is going to give us the top 10, or actually 11, top 11 engrams in 2014. So let's see. We can actually add with scores. True. So the most common words and phrases from 2014 RailsConf talk abstracts, not very surprising. The, to, and, a, of, in, you, how. Rails. OK, Rails makes the number 10. So there you go. Now we can also, let's just have a little fun here, see what some of the sort of top non-trivial ones are. Obviously, you could write some code, maybe kill stop words, stuff like that, if you don't care about them. But so, Rails can code this talk, most popular 2-word phrase, pretty good. How to Ruby developers. This looks pretty relevant, right? I mean, these are not words you'd be surprised to see in a RailsConf talk abstract. So those are the most common words. So we now have this. We have this for every year, by the way, so we can also do something. This is the same thing for 2011, whatever. And the last piece of code we're going to write is we need to be able to query this data. So on the actual sort of website or finished product, you're going to have to search for a term, and you're going to have to go look up in your data what are the relevant values for that term. And so how are we going to do this? Well, the first thing we've got to remember is that we normalize. Remember we did this normalize for engrams thing. So we have to do that again, because what if someone searches for a capitalized word or with something with punctuation? We have to process it the exact same way that we processed our input. Otherwise, it won't match. So let's just do that. And then we have this constant all years. And we're going to iterate through that with an object with a hash. Let's just build up a hash. That's probably the easiest way to do it. Do year hash. And the relevant Redis command, again, is zscore. So we can do redis.zscore. We're going to look up in the hash from that year the term. And we need to put this actually in the hash. And then we need to 2i that in case it's nil. OK, so this now, what does this say? All years is just 2007 through 2014. Go through each of those years, and then build up our hash so that the hash, the key of the year, maps to the value of the number of times that term appeared in that year. So let's, again, see if that works. Talk.query, Ruby or something. Cool. So in 2007, it was mentioned 52 times. 2014, 22 times. Whatever. We can, I guess we said Ember originally. And there you go. It was not mentioned until this year, which is also kind of telling. And so this is basically all of the kind of step 2 code you need, that's sort of the Engram calculation, store the results. And again, I'd reiterate, like, everything we just did is kind of trivially simple. Like, there's no fancy algorithms. It's just counting, putting stuff in the right data structure, accessing it in sort of the right way. And I just think there's something like pretty insightful about that you don't need to do fancy things all the time, and that often the coolest results will come from something simple. And so, as I said, the last thing we're going to do here is create this nice front-end interface that lets us investigate the results. Unfortunately, we don't really have time to get into that. It is all on the GitHub. But I will tell you, I use HiCharts. It's a nice library, front-end library, that makes it very simple to get charts up and running. So it's actually not that much code. And I've done this already. So let's start up a server. And let's fire up localhost. And so here we have Abstractogram is our app. So what are we going to search for here? Let's say I, you, we, or something. And there we go. So there it is. The number of times the word you appears in each year. Looks pretty flat. So these are kind of constant. Anyone have anything else they want to search for? Let's try Ember, Backbone. All right, let's say we got Postgres, I heard. I guess we could also say SQL. No one cares about Postgres this year. Service, SOA. Oh, there's sort of a rising trend of the service-oriented architecture. Anything else? TDD, that's a good one. TDD, testing, test-driven, how about? So there we go. I'm sorry? REST. That's a tricky one, though, because REST is also like a real word that, like the rest of the time we'll do something else. Refactor, let's say. DHH. Ooh, good, that's a good one. DHH. Oh, wow, peak 2011, peak DHH. Let's see, we got Heroku is a good one on the rise. We can just look at Ruby and Rails. This is actually, I think, pretty relevant. It's like, what are people talking about? Not Rails anymore. We got to find something new to talk about. It's like too many RailsConfs. And in fact, this actually came up at the, there was a speaker meeting or whatever, and everyone was talking about how their talks weren't actually about Rails. And maybe this is actually an insightful statement that the community has obviously gotten very large, and there's just a ton of other stuff to talk about. People have been talking about Rails for a long time. And so here I am giving a talk that's not really directly about Rails, but so maybe this is like a real trend that people are just finding other stuff to talk about, and that is pretty cool. So I promised that I would show you the repo or whatever on GitHub. You can just do bit.ly/RailsConf data. It's just the code, everything we've looked at today, plus some more stuff. It's actually running live on the internet, abstractogram.herokuapp.com. I figure the internet's probably not working, but let's see. Yep, classic. And otherwise, that is it. And thank you for listening. And I think we have time for questions.